or something like that. Alright, I'm recording. Alright, Chef Dog, I got a couple of tricks for you to put up your sleeve. A couple of these are just basic. They don't have anything to do with derivatives, but for logarithms, when you have a general function ln log or whatever, natural log or whatever, this will be used a lot. You can rewrite this as ln of f of x minus the ln of g of x. And there's proofs online or whatever. You've probably already seen this, but I'm just throwing it up here because you have to have it to do a lot of these. And then for the multiplication, it's plus. So subtraction and division go together, and multiplication and addition go together. I always remember this bar is like a minus sign, so it goes with it. And remember to bring the ln over to both of them. It goes to both of them. And then for multiplication, it's the addition. So you have the ln of f of x plus the ln of g of x. So those are two good ones to have in your back pocket. And then another one, which my instructor that I told you about was so cool, he called the Slitterbond property. And it's when you have the ln of some function raised to some power. And if you don't want to generalize, you could just say to the fifth power. For example, this becomes, you bring the 5 down, and it becomes 5 ln f of x, whatever the function is. And he called it the Slitterbond property because he said this was like a water slide. And it comes down the water slide and goes out front. So call it whatever you want. If you call it the Slitterbond property, your teacher probably won't understand what you're talking about, but it helped me remember it, so that's all that matters. So remember ln, natural log, or log, regular log, the exponent comes out front. Because you're going to need to be able to do that for these problems. Because that's just the logarithmic part, not the differentiation part. So keeping these in mind, you have f of x, which we're going to change to y. Well, write it again. Y equals x to the 3/4 x squared plus 1 under the radical all over 3x plus 2 to the 5th power. Alright. Now we want to find the derivative of this. So what we're looking for is we want to know y prime or f prime of x eventually. But in order to do that, we gotta break this down into something else that we can manage. So in order to do that,
Dad, Mom's not here. She's in her room.
we're going to take the ln of both sides.
Dad!
Hannah, I'm not talking to Mom. I'm talking to somebody else.
He's making a recording before.
Now this looks like this. So we have ln of y equals, and since we have this property in our back pocket, we can dissect this because we don't like division. We want to get rid of that. So then we have ln of the top part. And I'm going to go ahead and recognize that this all into the radical is to the 1/2 power. Hannah, please. And then that's minus. We got to bring our ln over according to our rule, plus 2 to the 5th power. Now, according to our Schlitterbahn property, we're going to know that we're going to bring this down the water slide over here. Sounds cheesy, but whatever. Gets A on test, so. And then this is like our multiplication red flag right here. We have our multiplication property of logarithms. Because you have a log of 2 functions multiplied together. So we'll break that down again. We're going to have ln of x to the 3/4. It's just all about breaking it down to the next level. Ln of x squared plus 1 to the 1/2 minus, we're going to bring our 5 down out front, ln of 3x plus 2. Now it's starting to break down into stuff that we can manage. All right. Break it down one more time. We can bring this down here. We have 3/4 ln of x plus 1/2, bringing this down, Schlitterbahn in it, x squared plus 1 minus 5 ln of 3x plus 2. I don't know if you can see that on there. Hopefully. No, just go, wait a second, Hannah. I'm in the middle of something. Now, we have a rule over here that we learned that the derivative of ln is 1/x, right? I'm second guessing myself. Yeah. So we're going to have, we can start breaking this down. And the implicit part is that we have 2 variables here. So we take the derivative of, we're going to start taking the derivative of all this now. So the derivative of ln of y is 1 over y times y prime. And this becomes 3/4 times 1 over x. No, wait, the 3/4. Yeah, the 3/4 stays. Yeah. The 3/4 stays because it's a constant multiple times 1 over x plus. And then here's the chain rule.
Can we bring that stuff Dad made yesterday?
I'm gonna make new stuff fresh.
1/2 times 2x
Leave that alone. I'm gonna make a new one, Hannah, at Nana.
plus 1
We can make it
times 2. Because the derivative of the inside is 2.
Put it in my bowl.
Wait, I already. No. I'm going to leave the inside the same the first go around. 2x plus 1 times 2x is the derivative of the inside. And then this one becomes 5 times 1 over, in this case, this is the x, so it's 1 over 3x plus 2 times the derivative of the inside, which, what this really is times x prime, but usually, in this case, it's just 1, so it doesn't matter. But whenever this x is an actual function, it's going to be times whatever the function is prime. So, in this case, the function is 3. The derivative of the function is 3, because the constant is 0, 3x just becomes 3. Now we can do some simplification. We can multiply both sides by y to get rid of the y on this side. So, and then we're going to multiply all this by y. So we'll have y prime equals y times all of this. So we'll have 3 over 4x plus, we're going to combine these two, so we'll have 2x over 2, which just becomes x times x squared plus 1 minus, we're going to take 5 times 1 times 3, and we'll get 15 over 3x plus 2, and that's all in brackets times y. But from the beginning, y is this without the ln. So all of this is going to get plugged back in. So that's the implicit part. This is the important part of implicit, is plugging this y back in. Because you have two variables, and whenever you have two variables, you have to have two formulas to solve it. And in this case, we're plugging back in the original formula. So, bringing this up here, we have y prime, which we're starting to get something that looks like a derivative here. And then y is, we're going to plug in, is that big mess. x to the 3/4 x squared plus 1 to the 1/2 power all over
Simba.
3x plus 2 to the 5th power, and that's all times the rest of this derivative that we've started here. 3 over 4x plus, we've simplified this to just x times, let's go ahead and distribute this because we'll get x times x squared is x cubed, x times 1 is x, and then minus 15 over 3x plus 2. So we've brought all this up here and we're multiplying it. So that's the way, that was what my instructor said is the final answer. Because if you want to go ahead and distribute this through, you can. But there's really no reason to. You're at the point now where you have a definite derivative. You have a defined f prime of x. And that's what we're looking for. And really, at this point, you have what you need, and you really just, you can't do anything else until you know what x is. And when you're given a point on the graph, and it says find the tangent line of the curve at that point of x, it'll give you x equals 2, and you start plugging in 2 everywhere there's an x, and then you actually have something to go off of. So that's all we can really do with that. That's all we want to do with it anyway.